Perfect. Okay. So let's see here. What do I do? So y equals 3 times log base 2. Someone help you out again. What's the equation again? Oh, there it is. X plus 5 plus 2. Okay. How would you do this without a calculator? I'm going to kind of give you, it kind of pains me to do it this way, but it's okay. I'll do it this way. I want to give you kind of a way that's might be a little more efficient so that you don't feel that you're taking too long to do this. What makes this 0? What makes the inside 0? So, and you can't log 0 because if you plug in -5 right now, you're trying to do this. 0 doesn't equal 2 to some power. I can't raise 2 to some power and make it 0. That's impossible. I just can't do it. So what I'm going to do instead, so I can't do -5. -5 is no good. No way. Don't do -5. But let's do -4. If x equals -4, what does the inside become? 1. What's log base 2 of 1? 0. That's 0. So you have 3 times 0 plus 2. Altogether, that's going to be 2, right? So that's your first point, -4 comma 2, which makes sense because we're going 2 up, right? That should happen. Now what I'm going to do is I'm going to plug in another number for x, but I have to go higher. I can't go lower. I have to go higher. So how high do you go? That's the part that might be a little challenging. But if you think about it, what's the next log I can evaluate if I'm doing base 2? I do log base 2, 1, which I know is 0. Well, what if I do log base 2? Well, hold on. I like that, what you said. But what if I do log base 2? I know it's 1, right? So x has to be -3 to make that happen, right? Because -3 plus 5 gets you 2. So notice I just kind of, I'm being intentional with what x values I'm plugging in. If I plug in -3, -3 plus 5 is 2. I can work that out now. Now that's 3 times 1 plus 2, I get 5. And I'll do one more for good measure. So you said -1, Jack. I like that. Why did you say -1 for x?
The inside is 4.
Good. So you're thinking 2 or 3 steps ahead. I love it. Yes, exactly. That's what you got to do. I'm not sure if any of you guys play chess or checkers, but I played checkers with my son. He's 7, but not ready for chess yet. But I was never really great at it. But to be great at chess, you have to think 4 or 5 steps ahead. Just that's the bottom line. Or like a good NFL head coach, like Bill Belichick, and was a Patriots fan. He's always thinking 5, 6 steps ahead. That's why he beats people all the time when he had Tom Brady. But bottom line is you got to think ahead, right? So if you think ahead, yeah, like what if I plug -1 for x? I get 4 inside. Well, what's log base 2 of 4? I know it's 2, right? Because 2 to the second power is 4. So -1's gonna be a good idea. If I do that, 3 times 2 plus 2, you get 7. Now I'm gonna plot those points. Switch colors so we have a different color to work with. Great. Okay. So let's see here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So it might help to understand how the basic graph looks. The basic graph looks like this. Y equals log base 2x. That's because you have a point at 1 comma 0. You have a point at 2 comma 1. So the point at 1 0, the point at 2 1, and it's just going to kind of rise like that. Also, if you plug in negative values for x, sorry, not negative values for x, decimal values for x, like 0.5 or 0.1, y would be negative. So there's a vertical asymptote at x equals 0. Because I shifted 5 left, where's my vertical asymptote now? I gotta go 5 left, exactly. There's my vertical asymptote. And then if I just plot the points, it makes sense on -4 comma 2, -3 comma 5, -1 comma 7. Sorry, I should make those a little more noticeable. And there you go. So it kind of looks like that. There's your graph. I didn't quite do it to scale, but it's okay. The domain is going to be all real numbers. No, sorry, I lied. X is greater than -5. The range is all real numbers. Okay, the range is all real numbers. That's what I meant to say. And x equals -5 is my vertical asymptote. So yeah, that's all. Okay, so that's how you do that graph. Since I'm recording this, Let's look at the solutions again. So yeah, so that will be a test question for sure. Just telling you right now. Any other questions about the first page? No? All right. Let's look at page 2, number 3. Here are the answers. So we're condensing. Definitely gonna be asking this on the test as well, which is again not till Thursday of next week, which is March 7th. And this will kind of get baked into other problems too, like solving equations we'll talk about today. So anyway, but yeah, you definitely need to know the skill, right? Maybe I won't ask like something like part A exactly, but something that it's part of another problem. You'll see what I mean by that when we do more work on logs today and tomorrow. Any questions on this though, like why these work the way they did, why they combined the way they did? No, we're okay. All right.
Can you explain H?
H, sure. Yeah, H is kind of a little crazy. Whenever you have 3 logs, it gets a little dicey sometimes. My suggestion is work from left to right. So you have a plus here. Just add more plus. Now you've got 2 logs, which is nice. That's your divide. This divided by this, done.
Okay.
That's it.
All right.
So what happens sometimes, people will just like gravitate towards the minus and they get confused. They say, oh, I got to divide these, but then they get kind of confused again to see another minus or a plus. My suggestion, so you're methodical, work from left to right. Because that's the core of operations anyway, multiplication, sorry, for addition and subtraction. Yeah. Work from left to right. So that would be just the methodical way. So that way you kind of slowly you're chipping away at it, right? Like, okay, get down from 3 to 2 and 2 to 1. So you take those baby steps, right? All right. 6, 129. That was kind of a funky one a little bit. Not sure what to make of that one. But you can move the 2/3 to the front. That's totally fine. Or you could evaluate it. Like if you evaluate it, I know that's cube root of 8 is 2 squares 4. You can do the 2/3 to the front, or maybe make that negative 2/3. That's another option. Then we can do it here if you're looking for other creative manners of doing this. You could move you could only move the 2 to the front if you want and make it like that. Or move the 1/3 to the front and make it like that. There's a lot of different ways you could do it. So part B, yeah, I kind of moved the -2 back. Then I evaluated, which is 1/25th, or I rose 1/5 square. So a lot of different ways you could do that one. For part C, you can move the BO to the front, or you could flip NA, make it negative BO, or move the O to the front. Or you could also move the B to the front. So anyway, there's a bunch of different options there. For 6, 133, you can cube root. I don't know if that is some nasty decimal. Just punch your calculator. Perfect, good. And for part B, that's just 5. X is 5. Because 3 to the 5th power, if you use your fingers, 3, 9, 27, 81, 243. And that's as far as I wanted you guys to get. This is just old stuff. Adding, subtracting, multiplying, rational expressions. Now, on our test next week, again, I'll give you guys more details about it tomorrow once I have a chance to organize kind of my thoughts and put in a more streamlined outline. We're going to ask you guys literal equations again. So you guys let me pull up the the previous test from Unit 2. So just so you know what we're going to put from Unit 2, I'm just going to kind of be as transparent as I can be. So I know that some of you guys had trouble on that last page. I'm asking this again. I'll answer that question for that time. Until you guys finally get it. If we have to wait till Memorial Day until we get to finals, so be it. It's like that analogy I gave you guys in was it Dark Knight Rises, right? Like the guy, Christian Bale, Bruce Wayne, Batman, he's trying to climb out and he keeps falling down. Finally he makes it out. So you guys are gonna keep doing it until we get it. I want almost 100% of you guys getting it. So I'm asking that again, just so you know. But not 7 and not 5, because I think you guys are good at that. But 6 for sure. I'll remind you, I'll tell you guys tomorrow and next week. Know that. And then something with matrices, I'll tell you guys tomorrow, because I want to make sure you guys review matrices again. So yeah. I've probably done with like all these. Oh, for this, probably Monday will be done, I think, for this unit. But I think we'll get most of it done this week though. Yeah, because it's a short unit. Anyway, let's keep moving. So, 6-121 is good, but it's not going to be on the test, just just good to review. Monty, go ahead. Exactly right. Yeah. Current stuff. Exactly right. Because the current stuff kind of draws on the first unit, which is on logs anyway. Because as math naturally does, it builds upon itself. These were the extra problems, by the way. If you did them, great. If you didn't, that's okay too. I think these are kind of good to do because this will make you better with the logs. So if you can do these problems, you're going to be great logs because these are actually a little more challenging than what was on the actual homework in the previous 2 pages, just so you know. And then 6-136, I'm not asking inverses, but again, something we need to do. So just in general. So anyway, let's move on to the notes, guys. So you guys put the homework away. Let's talk about the notes and get that done today. So here we're 6, 8. Okay, and oh, these notes are short. Nice. Okay, I kind of goofed because these are already filled out for you guys. I think you guys have it blacked out, right? Yeah, so I'll tell you what the blackouts are, and then we're just gonna do a couple word prompts and we're done today. And then homework will be pretty straightforward. Homework is right here. Yeah, I meant to use whiteout instead, but I couldn't find any, so I used a Sharpie. So kind of lazy. Homework you actually do in the worksheet itself, and that would be nice. Yeah, you guys should have a chance to work on homework today because I know you guys have a lot of classes and whatnot. So anyway, let me close. Keep that open. Actually, shoot. Okay. So yeah, I just need to keep that open for those students. Yeah, here we go. Let's talk about it. So log properties. This is stuff you guys already seen. So wherever you see it blacked out, and let me actually get your version in front of me so I know what you guys are seeing. Sometimes I don't know what you guys are seeing. All right. Yeah. So remember, and I'll highlight the stuff that you guys need to, or circle the stuff you guys need to write. So go and write this in where you see all the Sharpie blackout stuff. And let me just talk about it really quickly. So we did this in unit 1. We know this now. A equals M to the n. We know this. We just talked about this recently. That's breaking up like 2 logs with addition. You know this also this recently. Breaking up 2 logs in the minus. You know this. We roll the n to the back when you're next one, or if you see it time, roll back. We want to get back to the next one. Whenever these are the same, the log and the exponential, they undo each other. They don't technically cross off. Want to cross them off, but it's good there, so be it. But they undo each other to get n. Or if you raise a power to a log, those also undo each other to inverses, right? That's what's called inverse relation. The inverse relation, so you just get n and n in that case. I don't know what that's going to be, but I'll save it for tomorrow. I didn't create it. Yeah, I'm not prepared to do the activity. You guys need scissors and glue, and I didn't get those materials. It's kind of a cool activity. I'll show it to you guys really fast how it looks. Where the heck is it? Let's see, Dropbox, Algebra 2, spring semester, unit 3. Yeah, log property puzzle. It's kind of hard to tell. Wait, what? Why is it doing that? Okay, it looks a little busy. What you wind up doing, let me clear my screen for a moment, and we'll do this tomorrow. I think it's good thing to do tomorrow afternoon. I'm gonna cut. So first you need scissors. So you wind up cutting. Actually, yeah. So you wind up cutting these. It's like all these different just what 16 squares, right? No, like this one 16 squares.
And then you have to kind of line them up. Like, for example, you see like, kind of hard to read, but that's like 1/3 log x. I know that's the roll to the back and you become log x, all log cube root of x. So I have to locate that and line it up. So it's kind of like a puzzle in a way. Like you have to like line up the edges for what they're equivalent to. I can't find it right now because I'm drawing a little nuts right now. It's just too much in front of me, but I know it's there somewhere. But there it is right here. Yeah, so you like line up this and this, and these two squares have to like line up like that. So it's kind of a cool activity.
May I come with a prize or something? Or if you guys want extra credit, I can do that too. So anyway, but that's kind of a neat thing. So we'll do that actually. I'm not prepared to do it today because I need glue, because you need to glue them together and cut. You need scissors. We'll do that for tomorrow. I wasn't prepared for that today. But that's what's meant by the puzzle. So we'll save that for later. Here, again, I'm gonna have you guys fill out the things that are blacked out. And I'll explain what's happening so you understand what's going on. This is called the change of base formula. Okay, change of base formula.
So let's say we have 2 to the 5th equals 32, right? We know that's true. So if I were to work this out, obviously that's log base 10 32. It's 2 to the 5th, right? It's 32. Well, if you think about it, the 5 comes into the front. Right? Also, if you think about it, I could divide both sides by log base 10 to 2. So what this tells me is that I can actually, if I'm being asked to evaluate something that's not quite clear, like say log of one second here. Yeah, that kind of makes sense of this. Yeah, if I'm trying to do like log base by, sorry, log base 2.
Yeah, now I got it. Here we go. There we go. That's the connection, which apparently is not really made very clear in these notes. I'm just realizing that now. So here's the deal. We know this is true. Log base 2 of 32 equals 5. Would you guys agree if that makes sense? Because 32 equals 2 to the 5th power. And by what we're doing here, if I took the log of both sides, which now you see over here, and then if I move the 5 to the front, which I'm allowed to do, and then divide both sides by log base 10 of 2, 5 equals all that junk. Well, here's the thing. 5 also equals log base 232. So the connection here is this. The change of base formula is this: log base a of x equals log x over log a. Where both these logs here are common logs. So to do this one, you do that. Or to do this one, you do this. That's just another way you could do this. This is how I used to do logs before the calculus got really fancy. The calculus didn't have that subscript that's built into the TI-84. Let me show you the calculator. I think once I show you the calculator, it makes more sense. This is yet another example of how you could do it. Like, oh yeah, btx equals y. So this is the same thing as saying log base b of y. Those are the same thing, just so you know. So let me pull up the graphing calculator so you can see this actually a little bit better. So let's see here. Calculator 2022. Math departments. Okay, so for example, if I do log base 3, you guys know this now, right? Like alpha window, option 5. You guys know you could do this, right? And we know the answer is 5, right? We know this, right? You guys know this.
But when I was your guys' age, you had the older version, this didn't have this feature. This feature did not even exist. So what I had to do is I had to do
This log over here. And I actually had to type it like this. So that's common log, by the way, or base 10. It's still the same thing. If I want to get even more creative, I could do this, like alpha window. Like I could get really crazy here. Let me make this like 1.526. Okay, something really wacky. But let me put 243 in here. Divided by alpha window, option 5, 1.526, and plug in 3. You're still going to get the same thing. As long as the base is, it's called the change of base formula. You're allowed to do this if you didn't have some sort of, if you don't have a change of base or like the subscript, I guess you do common log. But it's just something that works. I think that's why I want to make you guys aware of. It's a formula that works. So there you go. All right, let's move on to the next page. Let's do some word problems, and I think we're all done. Okay, we did this back in the day, the finance formulas, and they kind of returned. They kind of returned the vengeance too, because now we kind of expect to do more stuff with it. And we'll give you the formula, by the way. Don't worry about it. You get the formula. You guys remember this formula? Yes, no, maybe. Yeah, I think we did in the fall. So you start at $3,500. You invest at 5%. It's done annually. And you want to figure how long it would take to double your money. Okay. So P is the initial deposit. A is the money you want after T years. Well, how much money do you want? What do we want to do? We want to what? Double. What's double 3,500? $7,000, right? Yeah, you're not going to invest my money. You're going to give me only $700 after that. Just kidding. And by the way, is number of times the money is compounded per year, but N is 1 in this case. And R, of course, is your percent interest as a decimal. Yeah, 0.05. And T is what? We don't know T. We're trying to solve for it. So I'll divide both sides by 3,500. Don't distribute 3,500, guys. Please don't do that. That's dissipating the order of operations. You guys are better than that. Please do not distribute that 3,500 to the 1.05. Can't do that. So you got this. All right. So far, we're okay. And again, I'll give you the formula. Not a problem. I'll give it to you. How do I solve for T? What do I do? Put in a log. You rewrite as a log equation. So you can do it two ways. Let me erase the other stuff because I think now you get the idea. I need space anyway. Hold on, let me move this. Ah, man. Hold on. So you can do it two ways. You could write it like this, log base 1.05 of 2 equals t. You could do it like that. Or you could take the log of both sides. Either way is fine. Either way is fine. So you could do method 1, which is rewrite as a log function. Or method 2, take the common log of both sides. If you take the common log of both sides, what happens to the t now on the right side for my second method? What happens to t here, guys? Goes to the front totally. And then you divide both sides by log 1.05.
Does it matter whether or not the T is in parentheses?
No, no. And if I work on my calculator, I'll clear the screen for a moment. So alpha window, option 5, 1.05 raised to 2 power. Or you can do this, log 2 divided by, so it's like the change of base formula in a way. So it works. Yeah, you get the same thing. So it's up to you. Either method's fine with me. Personally, I always did the second method when I was in high school. This is easy for me to understand. So whatever you guys are comfortable with, I'm totally fine with. But each case we got 14.2 years. So it takes about 14.2 years to double your money. So you could also do this in Desmos to check your work. Like if I would go to Desmos right now and say, okay, well, 2 equals 1.0. So if I go, hold on. Clear my screen. Y equals 2, or y equals 1.05 raised to the x power, and zoom out, zoom in. Yeah, see, same thing. So graphing wise, you could do it too. It's pretty easy. Yeah, so pretty easy there. Anyhow, let's look at one more example and we're done. Part B, how long will it take to triple your money if it's compounded quarterly? And we'll still use the same interest rate, okay? So A, here we go, 1 plus, again, I'll give you guys a formula, not a problem. So you want to triple your money. So now it's going to be 10,500, I think. You triple your money, 3,500. 1 plus, now what's n going to be if you're doing quarterly? What was that, sorry? Quarterly, 4. Yeah. Yeah, I mean, in college, I guess you take 3 quarters, but you could do a summer quarter too, I suppose. Yeah. So divide everything by 3,500. Technically, all that's being divided by 3,500. Those go away. And I'll need a calculator. So you have that. 88.437 divided by 4. You get 22.1 years. And there you go. So this word problem for sure.
Actually, I just wrote it. I wrote about the test. This test, this is the test. We're going to explain 3 test questions now.
I told you literal equations, graphing logs, and this one right here.
So you don't put the 4t in the calculator, you just divide by 4.
Yeah, afterwards, exactly right. Yeah, I did log base 1.0125. I decided to do it that way. If you wanted to, again, let me back up a little bit here. Another way we could approach this problem as well, do the method 2. This is method 1 what I did. If you want to do method 2, take log both sides. So I do common log. It's log 3 Yeah, same thing. Either way works. It's whatever you're comfortable with. But that's using the power property right now. You know this. Now you could do that. You have more flexibility now with what you can do to solve these problems. All right, I think I got really detailed about that. So number 1 is a word problem. There you go. You can work it out. So it's likewise with 2 and 3 and 4. And they got a bunch of other random stuff here. Yeah, just like graphing logs, rational expressions, valuing logs. So yeah, I think that we're good for today. And I'll work this out as well and share the answer with you guys. I'll work out while you guys are doing this. And I'll stop the recording.